Hello guys, let's get on with the lesson. We have finished with lesson number 3, in which we were looking at how to combine a number of terms of a logarithmic expression, combine all of it into one term. In this lesson we are going to do the exact opposite, and that is to take one single logarithmic term and split it up into different terms, okay, which is what you would say, you would refer to as decomposing a logarithmic expression. So let's just put that down. So this is going to be lesson number 4, and in lesson number 4, just like I have said, we will decompose logarithmic expressions, which is to say, think of what happens with cell mutation. This is called binary cell fission. So you have a single cell splitting into 2 or more cells. Binary here in this case means splitting up into 2. But we're going to use this idea to think about how a single logarithmic expression can be made to split up into different terms, something like this. So if I was given a single logarithmic term like that, I could split it up into the different forms, okay? So this is what we are doing in this lesson. It's going to be a little shorter than the other lessons we've had, and then in the next lesson, we're going to look at how to solve logarithmic equations, okay? Let's begin. Now, before we move on, I need to stress on some important facts about logarithmic expressions. We know this is the index notation of expressing a number, and this is the logarithmic notation of expressing the same number. We say that the two forms of notation are relatively inverse. We will discuss that once we have understood what functions are and what inverse functions are. All right. Now, the basis when a logarithmic expression is this, the a there refers to as the base. So when the base is 10, or the base is 2, or the base is the natural number e, we tend to simplify the expression, the log to base a of n, okay? So for example, if the base is 10, for example, x is log to base 10 of p, instead of all the time writing that base 10, we mathematicians all understand that we can simply write this without the base 10. So anytime you see x equals log of p, you will understand that that is base 10. In short, we simplify the writing of log to base 10 by leaving out the base 10 there. So anytime you see an expression log of p, then you must assume that is log to base 10. Okay, so it's a simple way of reducing the notation, so you don't have to write too much. Similarly, when you see log to base 2, so 6 is log to base 2 of 64, for example. The way to simplify log to base 2 is to leave out the 2 and also the o there. So when you see 6 is log 64, every time you see that, that means log to base 2. Okay, it's a mathematician's way of trying to simplify or to reduce too much writing of the same thing. Okay, and lastly, when you see the natural log e, so if a log is given to the base of the natural number e, we refer to that as the natural logarithm of y. So n is the natural logarithm of y, log to the base of the natural number e. So instead of writing log to base e like that, we simply write ln to imply natural logarithm. So the ln there means natural logarithm. It's expressed in French, which I cannot pronounce. Okay, so you start with logarithm and then natural means natural logarithm. Okay, so just keep this in mind. So whenever you see this expression, please attribute them accordingly. That is log to base 10, that is log to base 2, and that's the way to write log to base e. Okay, and you're going to see this expression as we move on in this activity. All right, so now let's begin. We are applying the laws of logarithm to decompose logarithmic expressions. All right, expanding logarithmic expression or decomposing logarithmic expression. You have a single logarithmic term. You want to split it up into several terms. All right, so here we have the first example. All right, Example B1, because in lesson 3 we had A's. Okay, so B1 then, express in terms of log of A or log of B or log of C or all the three, okay, any of the three. All right, here's the first question. We want to decompose log, and this would mean log to base 10, all right? So that means log to base 10. So log to base 10 of 1 over a power 4. Well, if you're going to answer this question, remember the laws of logarithm. We have a quotient. So we have a number divided by another number inside the logarithm. In other words, sometimes we refer to this as the argument. So the argument of the logarithm of the log expression, this argument has been expressed as a fraction, as one number over another, like A over B. So when you see that, then of course we use the quotient law, which I have included here, at least for this first example. We will not include these subsequently, but for the first one, let's do it. So we have this scenario. So if we're going to decompose, splitting up into more number of terms, then of course I'm going to use this law. So log of A over B is always equal to log of A subtract log of B there. And so in this case, we're going to have to take log of 1 and subtract log of A to the power of 4. Okay, I'll get rid of that law. And now I have to remember the law that we refer to this as the null value law. The log to any base, this is base 10, but the log to any base of 1 is always equal to 0. That is that law there. We've looked at this. So log to any base of 1. The log of 1 to any base is always 0, and that means I can get rid of this one. All right. We are left with that, but our answer, we now only have A, but our answer is required in terms of log of A, not log of A power 4. However, I can recall law number 3, which is actually the power law, which says that if 4 appears as a power inside the argument, then I can move that 4 to the side. That is the power law there, okay? That's the power law, and so I can move my 4 to the side like that, and so I can express the result of this law, the result of this expression as the negative of 4 log of A. I've expressed it in terms of A. Since there is no B in the expression, my answer ends there. Okay, I hope you understand this. Now subsequently we will use the laws, but I will not be putting them there. We will mention them. I want you each time to pause and think about which law is relevant in solving the questions that are coming up. So we are going to, this was A, now we go to B. Okay, so B says express the log of BC power 3. So the argument now is BC power 3, it's base 10 there, log to base 10 of BC power 3. All right, now which law would be relevant here? If you think clearly, this is the contents inside the argument are multiplied. Okay, so we need the multiplication law or the product law, which says that log of A times B is log of A plus log of B. So we're going to use that. So we can split that into log of B plus log of C to the power of 3, because the two of them have been multiplied in there. Okay, and now we can use the power law, and I know if 3 is there, I can move it, since what we are required to give is in terms of log of C, not in terms of log of C power 3. And so what I'm going to do is I'm going to move that 3 to the side of the log there, and my final result is going to be log of B, which is that first term there. And for the second term, we're going to add 3 times log of C, and that's the answer to this question. We have decomposed log of BC power 3 into log of B plus 3 log of C. As you get more confident with questions like this, you are able to just look at it and give this answer straight away without that first step there. All right, let's look at the next one. Obviously, pause the video and try to see how to go about it. All right, so the first thing, of course, is to notice that the cube root of C can be expressed as C to the power of a third. I hope you know that at this stage. By the time we are doing this, obviously all of us have gone through exponents, or what somewhere we refer to as indices. All right, so the cube root of c is the same as c to the power of a third. And so if we're going to express this in terms of log of a, b, and c, then we have to decompose the argument of that logarithmic expression. And if numbers are multiplied, so we have a multiplying the cube root of c, so if they are multiplied inside the argument, we are going to add the individual logarithm. If something is subtracted, so it's in the denominator, we will subtract the, if something is divided, we will subtract the logarithm. Okay, so let's see. All right, so the cube root of c, we've seen, can be expressed as c to the power of a third. So then when we begin, then we have log of a, we have to add to log of c to the power of 3, because the two are multiplied, so there we use the product rule. But this is divided, and because it is divided, we use the quotient rule, so it is subtracted, right? And so we'll say minus log of b. Now, making use of the power law, the third, which is the power of c there, can move to the side. And so what I have finally is going to be log of a, and I'll add a third log of c. Okay, like that, because c has moved to the side. And then I'll subtract the log of b, and that is my answer to the question that I've been asked. So you can see my expression has been decomposed into individual terms containing a, b, and c. Log of a, log of b, and log of c, like that. Okay, let's go to the next one. Part D. Pause the video and try to solve this question. Express in terms of, and this one is going to be in terms of a, log of a, and log of b. So of course, the square root of a over b can be split up, and we can write this as the square root of a divided by the square root of b. So square root of a divided by the square root of b, this can be expressed as this here. We can express that as log of the square root of a over the square root of b, which in turn, again, remember the square root means power half, so we could express this as log a power half divided by b power half, and then we can proceed after that. Okay, so be sure you understand why this can be expressed like this. All right, so keeping that in mind, we can express this then as log of a over b power half, which is the same as splitting it up like I said earlier. We can express it like that. And now we have a quotient, a power half divided by b power half, inside our argument. And so we can split that using the quotient law, and we have log of a power half minus log of b to the power of a half, like that. And using the power law, we can move the half to the side. So the half to the side of log of a, and the half here to the side of log of b. And I will end up with a half log of a minus a half log of b, like that. And that is the answer to that. All right, so we have decomposed log of the square root of a over b. Okay, here's the next one. This is E. Pause the video and try to solve this one. How do we think about the solution to this? What are the first laws that come to mind to use here? Okay, assuming you've tried it out, of course, I see a quotient in the argument. The argument there is a quotient, and at the denominator, we have a times b power 4. Okay? A quick way to reason out here is to always say, if you look at the argument, there are terms above, there are expressions above the division in the numerator, and there are expressions in the denominator. Anything, any expression or any number that appears in the numerator, if they are multiplied in the numerator, we will always add the individual logs. if they appear in the denominator, we will always subtract the individual logs. So this would be, for example, log of 1 minus log of a minus log of b to the power of 4, because both a and b power 4 are in the denominator, so their individual logs will be subtracted like this. Okay, so we have log of 1, and we will subtract log of a, and we will also subtract log of b to the power of 4. Why are we subtracting log of a? Because it is divided. Why are we subtracting log of b power 4? Because it is also divided. Okay, so we 1 divided by b power 4. So a and b power 4 are in the denominator. Anything that is in the denominator, we will always subtract. Anything that is in the numerator will be added. All right, now we can employ two laws here. One is the null value law. So log to any base of 1 is 0. The other one is the power law, which means we can move this 4 onto the side like that. So let's see. So by null value law or rule, that number there becomes 0, so I can get rid of it. And the b there, b power 4, the 4 can drop, and so I can express my answer as negative log of a minus 4 log of b. And that is my answer, my friends. Okay, I hope that made sense. Question F, please pause the video and try to solve this by yourself. Notice that is the cube root of several letters in there, A, B, and C. So how do we simplify this? So notice that the cube root means power a third, but it is everything inside that, the argument of the radical sign there, everything inside is power third. So I could express this like that. And now we know that when we expand, if we get rid of that bracket, in other words, we expand the power third, if we bring it in, it is distributed to each of those letters A, B, and C. For example, this is going to be log of A power 9, but 9 is also power third, so I'll say times a third there, right? B is to the power of 3, so we will have to multiply by a third. And C is to the power of 1, so this is just going to be a third. And of course, this here will end up being, this is 3, so that's just A power 3, and 3 times a third is just 1, and this remains as a third. So we end up with log of A power 3, B power 1, and C power a third. B power 1 is just B. All right, so with that simplification in mind, let's see. We can express this as log of A power 3, because a third times 9 is 3. B power 1, because a third times 3 is 1. And C power third, because a third times 1 is a third. Okay, so we end up there. And now we use the product law, because all the elements in there have been multiplied. It's A power 3 times B times C power third. So because the elements inside that argument have been multiplied, we need the product law, which therefore tells us that we will add the log of A power 3 with the log of B and with the log of C power half, like that. So log of A power 3 plus log of B and plus log of C power a third. I hope that is clear. Keeping that in mind, now we make use of the power law, which allows us to move the 3 to the side and the third to the side, and I end up with 3 log of A. Okay, 3 has moved to the side, and plus log of B, and plus a third log of C, like that. And that is the answer to question F. I hope you tried and that you got the same. Okay, right. At this juncture, I want us to try some examination type questions from different examination bodies, the IB, AP, and so on, right? Let's see some of the questions from these exam bodies. Let's start with the first one there. Question 1 says find log to base, question 1a, find the log to base 3 of 27, and part B says basically part B will follow on from part A. Usually this is how exam questions are like. Somehow you will usually use the ideas you get in part A to be able to continue in part B. So the common way of asking question would be hence or otherwise, given that this is the case, can be expressed as this, find the value of P and Q. So the command term that is normally used here would be, after you've solved part A, it would be hence or otherwise. It could be hence show that, or hence or otherwise show that, okay? And those two are different. If it says hence show that, then it means part A has to be used. It's a condition that requires you to use your result from part A to solve part B. But if it says hence or otherwise, then you have been given a leeway to use any other method you know to solve the problem. However, the fact that it's saying hence or otherwise is also an indication that the best way to solve the question is to use your result from part A. Okay, so in this case, we are going to have to solve this by hand. I prefer it that way. So if we're going to find the log to base 3 of 27, of course, we want to write this as, so the first thing we want to do is to write this as log 2 base 3. And what we're going to do is write 27 in terms of 3, and I know I can write 27 as 3 power 3, and then I can use my power law to move this to the side, and I would have that move to the side there, so I have 3, and I'll say log 2 base 3 of 3. And from the unity law, we know that log 2 base 3 of 3 is 1. How do we know that? Because 3 power 1 is 3, and if I change this to logarithmic notation, I would say this one here, 1 is the logarithm of this 3, logarithm of this 3 here, when the base is 3. So I know log to base 3 of 3 is going to be 1. Log to base A of A is always equal to 1. It's called the unity rule, or the unity law, if you like. Okay? And so if log to base 3 of 3 is 1, then I have 3 times 1, and so this is just 3. Okay? So part A of the question is just 3, and obviously we are making use of that part to solve the next part of the question. Forgive me for this. I'm going to erase this, but remember what we found there, log to base 3 of 27 is just 3. I'll erase this. Okay, so part B of the question. So part B of the question says that given that log to base 3 of 27 power x over 9 power y can be expressed as this, find P and Q. Okay, and so obviously we can see that the argument is a quotient. It's something divided by another. So of course the first thing I want to do is to split that into 2 terms, and that's going to be, the first thing I do, I express this as log. So that is going to be, let me use a different color. So this becomes log 2 base 3 of 27 power x, and because it's quotient, this is going to be minus log 2 base 3 of 9 to the power of y, like that. And now I can express 27 as 3 power 3. So this is log 2 base 3 of 3 power 3 x. 3 power 3 power x is 3 times x there. And this becomes minus log 2 base 3 of 3 power 2, that's 9, and then times y there. Okay? Then I can make use of law, the power law, to move this power to the side, and I end up with, I'll write this on the side here, I end up with 3x log 2 base 3 of 3, and I'll say plus, or it's not plus, it's minus, so minus there, we get 2y log 2 to base 3 of 3. And with our knowledge of the unity law, we know this bit here is 1. I'm going to use this. So I know this bit here is 1. Okay, and the same thing here is 1. So I'm left with 2y there, and I'm left with 3x. So I can write my answer then as 3x minus 2y. And so if we're being told to express as px plus qy, then clearly the value of p there is 3, and the value of q is -2, like that. And that is how this exam question would be answered. As you can see, we are still just making use of the laws of logarithm to solve a question like this. All right, let's look at the next question, question number 2. Obviously, I want you to try these questions out before you see my solution, so please remember to pause the video and try the question yourself before you look at my solution. So here's the next question. Let R be ln2 and S be ln of 7. So this, I hope you remember, this means log to base e of 2, and this is log to base e of 7. Okay, so ln means natural log, which is log to base e. Of course, I want you to remember that e is the irrational number. E can be expressed as 2.718, and it is an irrational number that continues on. The decimal numbers continue to infinity, non-recurring, non-terminating. Okay, one way to find e, this we will discuss later in these classes, but one way to get e is to find the value of the limit as n tends to infinity of 1 plus n over power 1 over n. So as n gets bigger and bigger, what does this value become? So try a value of n of say 1 million, then try a value of 10 million on your calculator, and the number you get in here is going to be your value of e. So as n becomes bigger and bigger, what you get in here is going to get closer to the value of e. Already you should see these first 3 decimal places. If you have say 10,000 for the value of n there, it should already give you these first 3 decimal places. Try it out if you get a moment, but it's not important. Just to remind you of what e, the natural number e is. We get this a lot in financial mathematics, sequences and series, particularly geometric progression. You will be seeing that. Another place where you see this is actually in calculus, but we will wait with that for now. Just remember, ln means log to base e, where e is actually this number here. We don't need to know the value of e. Actually, we know the value of e, but we don't need to know this mathematics to be able to continue with these questions. So it is just a by the way. Right, so let's look at this one. Write the following in terms of r and s. So the first one there, we want to express that in terms of r and s. We are given log ln of 7 over 2. So of course, by way of the quotient law, because the argument there is a quotient, in other words a ratio of 2 numbers, we must express this as ln, so ln of 7 minus ln of 2. And this clearly, we were told that ln is s, ln of 7 is s, and ln of 2 is r. Therefore, I can simply express this as s minus r, and I'm done with this one. Okay, the next one there says ln of 14. Well, ln of 14 is the same as ln of 2 times 7. Okay, and so this is a product, so it's our job to know that we can get 2 and 7 from here. And so ln of 14 is ln of 2 times 7, which is ln of 2 by product law plus ln of 7. And so this is the same as r plus s, or s plus r, doesn't really matter. And that is expressing ln of 14 in terms of r and s. It is as simple as that. Let's look at the next one. Here's the next question, number 3. Evaluate the expression. Evaluate the expression. So find the value of this expression. Log to base of, so square root of a is the base. So the whole square root of a is the base. And then we have the argument a to the power of 2 over 3. So when you get questions like this, I think I've said this in video number 3, when you get questions in where the base is complicated like this, so it's also a square root, or the base is larger than the number itself, or the argument, or the base is it's a fraction, or it is a radical like what you see here. When you get scenarios like this, the best thing to do is to change the base. So what we're going to do is we're going to change the base of this expression, and I'm going to use base a, okay? And that's the best way to solve this. Why am I using base a? Because I'm seeing a appearing everywhere there. So I'll write, so change of base says that if I have log of m, log to base m of n, I can express this as log of n divided by log of m. But I can now change my base. I can use any base. I can say base k there and base k there. So as long as I maintain the same base for the top and the bottom, I have changed the base of this expression. So I want to use this idea to simplify or evaluate the logarithm that I've been given. In fact, I'm not going to erase that. Let's just go on. So I'm going to write here log of the number itself, which is a to the power of 2 over 3, and I'm going to divide that by the log of square root of a, which is a to the power of a half, like that. And I'm writing this to base a. So I've decided I'm going to use base a. Now I can use the power law to move these powers to the side, and that gives me 2 over 3 log to base a of a. You can now see why I chose base of a, because log to base a of a is 1. And in the denominator, I will also have a half log to base a of a, because a half will move to the side according to the power law. And that leaves me, since log to base a of a is 1, that's 1 and that is 1, or if you want to think, you can cancel them. And you have 2 over 3 divided by 1 over 2, which is the same thing as 2 over 3 times 2 over 1, which is 4 over 3. And so the value of this expression here is in fact 4 over 3. We have evaluated the expression log to the square root of a to the base of the square root of a power 2/3. Okay, I hope you get it. Let's see the next. I think we have one more. Okay, let's move to the next exam type question, and that is 3 power 2 log to base a power 3 of a. So notice the base there is a to the power of 3, and the argument is a. So again, a question like this can be daunting, and this is law number 6, the function and the inverse function law. Actually, all I need to do there, the only thing is this is base a power 3. If it was just base a, that would have been very, very easy, but it is base of a to the power of 3. So I'm going to have to change the base of that power of 3. Okay? So what I'm going to do here is I'm going to write this as 3. So this becomes 3 power, and I'm going to move that 2 back up so that I have log to base a power 3 of a power 2. Okay, so I've moved the a back up. And now I'm changing the base of this exponent here. So I'll write that as 3 log of a power 2 over log of a power 3. Okay, I can now move my 2 and my 3 back, and I can decide what base I want. Because I'm changing base, I decide I'm making it base a, because before that it was base of a power 3, not base a. Now I make it base a, And this becomes, I can now write this as 3 to log to base a of a divided by 3 log to base a of a. Log to base a of a is 1, and so this simply becomes 3 power 2 over 3, if you like. Okay, so that's the same as the cube root of 9. Okay, this is the cube root of 9, or basically you can leave your answer like that. There's no big deal about it. That will be it. So we have evaluated this expression there. I hope that you get it neatly as it is. Okay, if you have any question regarding this, please let me know and we can go through it again. Okay, let's look at the next one. Question number 4. I believe this is probably the end of it, but we'll see. Given that y is 3x squared, I think this is coming from Excel. Given that y is 3x squared, show that the log to base 3 of y is 1 plus 2 log to base 3 of x. This is simple. Let's see. So we are saying y is 3x power 2. So obviously the best way to go about this is to take log to base 3 of both sides. Okay, if I take the log to base 3 of the left hand side, I have to do the same on the right. So I'm going to take the log of both sides. So I'll have log to base 3 of y, that's the left hand side, must be equal to log to base 3 of 3x squared, like that. Okay, and now what we have to do on the right hand side is to decompose it into individual logs. So the left hand side remains log to base 3 of y must be equal to log to base 3 of 3. These are multiplied, so it has to be plus product law, and this is going to be log 2 base 3 of x squared. And so using the power law, the 2 can go on the side, and I have log 2 base 3 of y must be equal to, the unit law tells us that log 2 base 3 of 3 is 1, so this becomes 1 there. And I say plus, the power law tells me I can move 2 to the side, and this becomes 2 log 2 base 3 of x. And I believe that is what the expression is giving us up there. It is really, really simple. This would be what, let's see, this taking log of both sides. I would probably give a mark here for taking the log of both sides, a method mark there. Opening this, decomposing this would probably give me another mark, 1 mark for decomposing it into 3 times x squared. That would be one other mark. I would probably give a mark here, maybe a mark there for knowing that log to base 3 of 3 is 1, and a final mark here for moving the 2 to the side. Or maybe that would be the case, and then this would be answer given to suggest that this answer has already been provided. So this would probably be about 3 marks. Okay, so we will be looking at more of these examination type questions in video number 6, where I have gathered a number of examination questions from the different exam bodies. So we will take a look at those in video number 6. In video number 5, we'll be solving, we will see how to use logarithmic equations, logarithmic laws to solve logarithmic equations. And then in video number 6, we will look at different types of exam questions, and we will be combining all the method and tricks that we've used in video number 3, video number 4, and video number 5. Okay? All right. What I have here is a set of problems that I want you to try out. I also have answers. So you will pause the video and look at the problems, and then once you are done, you can look at the answers, which I'm also going to give here directly. Pause the video, or at least take a picture, try them out, and then when you're done, you can take a look at the answers that I'm giving now. All right, let's hope you get these same answers. If you've done the A correctly, you should get that as the answer. We are using the product law. If you have done it correctly, the answer to question B should be log of A minus log of B. If you've done part C correctly, your answer should be log of A plus a half log of B plus a half log of C. And if you've done part D correctly, your answer should be log of C minus a half log of A minus a half log of B. If you've done part E correctly, your answer should be 3 log of A minus 2 log of B minus 5 log of C. Notice that if they are in the denominator, they are always subtracted. The logs are always subtracted. Okay, same thing there. Okay, same thing there. All right, and finally, if you've done question F correctly, you should get negative, because log of 1 is going to disappear according to the null value law or rule. So you should get negative a half log of A minus a half log of B. Okay, I hope that you've enjoyed this video. I will see you hopefully in the video number 5. But before we go, let's just summarize what we've done. Effectively in video number 4, here's a recap. So what we've learned here is we've used the laws of logarithms, and these are the laws, to decompose a logarithmic expression. Okay, what do we mean? That if you're given an expression like that, you can split it up into the constituent terms. Okay, this is what we've actually done. I hope that you are able to do this henceforth, and I will see you in the next video where we will be solving logarithmic equations, and these tricks will become invaluable when we get to that stage. I have included some questions in the comment section to help you with further practice of this. You can also get to my website where I will have put a worksheet on the same task. Okay, take a look at it. This brings us to the end of this lesson. In case you are seeing these videos for the first time, please consider subscribing to our channel. And also, if possible, try to share the videos with others who might also find these lessons useful. There are so many people out there who do not have teachers because they're in a state of war, or something is happening that makes it impossible for them to get to school. Sharing the videos goes a long way into supporting those who may not be able to have the same opportunities as we do. All right, so thank you very much for doing all 3 if you can. I will see you in video number 5.